Cloud computing, a new era of computing. Get to know everything. Welcome to TechieSpod, where you will get all the information on interesting topics and blogs on it to read. If you are not subscribed yet, then you are missing out something. So, here we go. Cloud computing. Cloud computing is virtually availability of computer system resources, especially data storage, cloud storage, and computing power, without direct active management by the user. The term is generally used to describe data centers available to many users over the internet. Why to use cloud computing? In 21st century, the need for speed, high-end processing, data capabilities, machine independency, accessibility to all makes the way free for cloud computing. Because in this busy world no one has the time to store data in physical drives and to buy high-end GPU for work, so they eventually switched to cloud computing as best alternative, which increased the demand of cloud storage and computing overnight. Let's us firstly discuss in deep about the concept of cloud. Cloud computing has two aspects. The most common refers to running workloads remotely over the internet in a commercial provider's data center, also known as the public cloud model. Popular public cloud offerings, such as Amazon Web Services, Oz, Salesforce's CRM system, and Microsoft Azure. Today, most businesses use this kind of cloud computing to ensure long durability and safety in terms of data. The second aspect of cloud computing describes how it works, a virtualization pool of resources, from raw compute power to application functionality, available on demand. When customers procure cloud services, the provider fulfills those requests using advanced automation rather than manual provisioning. The key advantage is the customer does not need to buy specific hardware requirements for different projects, she just need to request it from the provider in less amount than physical one. The availability of high-capacity networks, low-cost computers and storage devices, as well as the widespread adoption of hardware virtualization, service-oriented architecture and autonomic and utility computing has led to growth in cloud computing. Though service-oriented architecture advocates everything as a service, cloud computing providers offer their services according to different models, of which the three standard models per NIST are infrastructure as a service IaaS, platform as a service PaaS, and software as a service SaaS. These models offer increasing abstraction. They are thus often portrayed as layers in a stack: infrastructure, platform, and software as a service, but these need not be related. For example, one can provide SaaS implemented on physical machines, bare metal, without using underlying PaaS or IaaS layers, and conversely one can run a program on IaaS and access it directly, without wrapping it as SaaS. Advocates of public and hybrid clouds note that cloud computing allows companies to avoid or minimize upfront IT infrastructure costs. Proponents also claim that cloud computing allows enterprises to get their applications up and running faster, with improved manageability and less maintenance, and that it enables IT teams to more rapidly adjust resources to meet fluctuating and unpredictable demand, providing the burst computing capability, high computing power at certain periods of peak demand. Cloud providers typically use a pay-as-you-go model, which can lead to unexpected operating expenses if administrators are not familiarized with cloud pricing models. Father of cloud computing. Cloud computing is believed to have been invented by Joseph Carl Robnet Licklider in the 1960s with his work on ARPANET to connect people and data from anywhere at any time. Cloud types, execution model. Private cloud. Private cloud is cloud infrastructure operated solely for a single organization, whether managed internally or by a third party, and hosted either internally or externally. Undertaking a private cloud project requires significant engagement to virtual the business environment, and requires the organization to reevaluate decisions about existing resources. It can improve business, but every step in the project raises security issues that must be addressed to prevent serious vulnerabilities. Self-run data centers are generally capital-intensive. They have a significant physical footprint, requiring allocations of space, hardware, and environmental controls. Public cloud. Cloud is called a public cloud when the services are rendered over a network that is open for public use. Public cloud services may be free. Technically, there may be little or no difference between public and private cloud architecture. However, security consideration may be substantially different for services, applications, storage, and other resources that are made available by a service provider for a public audience and when communication is effected over a non-trusted network. Generally, public cloud service providers like Amazon Web Services, Oz, IBM Cloud, Oracle, Microsoft, Google, and Alibaba own and operate the infrastructure at their data center and access is generally via the Internet. Oz, Oracle, Microsoft, and Google also offer Direct Connect services called Oz Direct Connect, Oracle Fast Connect, Azure Express Route, and Cloud Interconnect respectively. Hybrid cloud. Hybrid cloud is a composition of a public cloud and a private environment, such as a private cloud or on-premises resources, that remain distinct entities but are bound together, offering the benefits of multiple deployment models. Hybrid cloud can also mean the ability to connect colocation, managed and/or dedicated services with cloud resources. A hybrid cloud service crosses isolation and provider boundaries so that it can't be simply put in one category of private, public, or community cloud service. It allows one to extend either the capacity or the capability of a cloud service, by aggregation, integration or customization with another cloud service. Cloud architecture. The systems architecture of the software systems involved in the delivery of cloud computing typically involves multiple cloud components communicating with each other over a loose coupling mechanism such as a messaging queue. Elastic provision implies intelligence in the use of tight or loose coupling as applied to mechanisms such as these and others. Cloud engineering. Cloud engineering is the application of engineering disciplines to cloud computing. It brings a systematic approach to the high-level concerns of commercialization, standardization and governance in conceiving, developing, operating and maintaining cloud computing systems. It is a multidisciplinary method encompassing contributions from diverse areas such as systems, software, web, performance, information technology engineering, security, platform, risk, and quality engineering. Security issues. Cloud computing poses privacy and security concerns because the service provider can access the data that is in the cloud at any time. It can accidentally or deliberately alter or delete information. Many cloud providers can share information with third parties if necessary for purposes of law and order without a warrant. That is permitted in their privacy policies, which users must agree to before they start using cloud services. Solutions to privacy include policy and legislation as well as end users' choices for how data is stored. Users can encrypt data that is processed or stored within the cloud to prevent unauthorized access. Identity management systems can also provide practical solutions to privacy concerns in cloud computing. These systems distinguish between authorized and unauthorized users and determine the amount of data that is accessible to each entity. The systems work by creating and describing identities, recording activities, and getting rid of unused identities. Merits and demerits. Merits. Easy implementation. Cloud hosting allows business to retain the same applications and business processes without having to deal with the backend technicalities. Readily manageable by the Internet, a cloud infrastructure can be accessed by enterprises easily and quickly. Accessibility. Access your data anywhere, anytime. An Internet cloud infrastructure maximizes enterprise productivity and efficiency by ensuring your application is always accessible. This allows for easy collaboration and sharing among users in multiple locations. No hardware required. Since everything will be hosted in the cloud, a physical storage center is no longer needed. However, a backup could be worth looking into in the event of a disaster that could leave your company's productivity stagnant. Demerits. No longer in control. When moving services to the cloud, you are handing over your data and information. For companies who have an in-house IT staff, they will be unable to handle issues on their own. May not get all the features. Not all cloud services are the same. Some cloud providers tend to offer limited versions and enable the most popular features only, so you may not receive every feature or customization you want. Before signing up, make sure you know what your cloud service provider offers. Doesn't mean you should do away with servers. You may have fewer servers to handle, which means less for your IT staff to handle, but that doesn't mean you can let go of all your servers and staff. While it may seem costly to have data centers and a cloud infrastructure, redundancy is key for backup and recovery. No redundancy. A cloud server is not redundant nor is it backed up. As technology may fail here and there, avoid getting burned by purchasing a redundancy plan. Although it is an extra cost, in most cases it will be well worth it. So, guys, this all about this topic. Don't forget to like, share and subscribe. That's all for this video. I hope you all like it. Please follow us on Instagram, Facebook and Twitter. The links for the following are given in description. Thank you.